Hey y'all, so here we go. We're going to factor some trinomials where A is not 1. And what I mean by that is we've got a trinomial in the form of ax squared plus bx plus c, and this leading coefficient is not 1, which means we have a number in front of our x squared. And just in case you didn't watch my video where we factored a trinomial where A is 1, I am going to run through these real quick on how to put our signs. So when we factor these trinomials, we're going to open up our two sets of parentheses. And this sign right here tells me that my signs are the same. The signs that I put over here in my binomials. This sign tells me that my signs are positive. They're both positive. So I'm come over here with my plus and my plus. If I have ax squared minus bx plus c, the signs are the same, but now they're going to be minus. So when I open up my two sets of parentheses, I can put minus and minus. But if I have the case of ax squared plus bx minus c, then when I open up my two sets of parentheses here, this second sign here tells me that my signs are different, meaning I'm going to put a plus and a minus. And then this plus sign right here means that of my factors, my bigger number goes with the positive. And then the last scenario, ax squared minus bx minus c. Again, my signs are different in my set of parentheses. And the way I'm going to show you to factor these is it's not going to matter where you put your plus and your minus. And I'm actually going to show two different ways to factor these. One is going to be a way that in the beginning it's wrong, but in the end it works out. And then the other way I'm going to show is where you're going to factor by, you're going to need to be able to factor by grouping. And so I do have a video going over factoring by grouping. So if you need to brush up on that, you can, but ultimately you're going to get to the same answer. And like I said, I'm going to show you both ways. And I'm going to work with number 2 just because I'm going to work with the ones on the right side just because I've got more writing space over here. So looking at number 2, I'm going to do this the way where in the beginning it's wrong, in the end it works out. So I'm going to just go ahead and jump down with my two sets of parentheses because I've already looked at this. I don't have a greatest common factor because that's the number 1 rule in factoring. And so in this way, I'm going to say, okay, well, the signs that I need to put down in my binomial have got to be different because this second sign over here in my trinomial is negative. It's minus. This sign right here tells me that my bigger factor is going to go with the plus. Now, this is the part where I tell you it's wrong, but just do it anyway. I'm going to come down here with 2n and 2n. And my next step is I'm going to take 2 times 9, and that's what I'm going to find the factors of. So I've got 1 and 18, 2 and 9, 3 and 6. Now, because my signs down here in the binomials are different, then I'm going to find the difference of my factors. And I want the difference, I want the factors that have a difference of 3. And because my 3 in my trinomial is positive, my bigger factor goes with the plus. And this is the point where we undo our wrong. We always have to, when we're doing it this way, we always have to go back to our binomials and look for a greatest common factor. 2n and 6, there is a greatest common factor of 2. 2n and 3, I don't have a greatest common factor, and that's fine. But what needs to happen is the product of our greatest common factors needs to be this. And so that is what I have down here. And so when I simplify this, I wind up with n plus 3, 2n minus 3. And if you want to check and make sure we did this right, we got 3 times 2n is 6n. N times negative 3 is negative 3n. And when I take this sum, I wind up with my 3n, which is what I've got as my second term in my trinomial. I'm going to show that one more time, but that way with number 1, and then I'm going to go back and show the way where you wind up having to do it by grouping. So here on this number 1, I'm going to come down 2 sets of parentheses without even thinking 3p, 3p. This second sign right here tells me that I'm going to be working with different signs down in my 2 binomials, down in my parentheses. And then I'm going to take 3 times 5. That's what I'm going to find the factors of, 15, 1 and 15, 3 and 5. Because my signs down here in the parentheses are different, I'm going to get the difference of my factors. And I want the difference of 2. So I'm going to work with 3 and 5. Because we have this negative right here, my bigger number goes with the minus. And this is the point where we have to look at each of the binomials and take out a greatest common factor. And so we wind up with p plus 1, 3p minus 5. Now going back to number 2, I'm going to factor this where we got to wind up using grouping. So I'm going to rewrite my plus 3n in a way that I wind up with 4 terms instead of 3. And so what I do is I still take my 2 times 9. And I still got my 18, and I erased them, but I'll do it again. So because of this minus right here, we need a difference of our factors again. So we've got 17, 7, and 3. So I'm still after this 3n. So the way I want to write this is I've got 2n squared. I've got plus 6n minus 3n, and then minus 9. So what you can see is this plus 6n minus 3n is my 3n. And now when I go through and I factor this by grouping, I'm going to look at my first 2 terms and my second 2 terms. In my first 2 terms, I have a greatest common factor of 2n, so that's what I'm going to take out of there. And then I'm left with n plus 3. In the second 2 terms, my greatest common factor is not only a 3, but it's a negative 3. So when I take a negative 3 out of negative 3n, I'm left with a positive n. And then I've got negative 9 divided by negative 3 is a positive 3. And so my result is I've got that n plus 3 in both terms that I'm going to pull out of there. And then I write down what's left. 2n minus 3. So that was 2 different ways you might want to rewind back to the beginning whenever I did that one the one way. But here on number 4, I am going to do them both ways side by side. So the first way is where we just drop down with our 2 sets of parentheses. Both signs are the same. Both of them are positive. And then I just come straight down here with 5 in, 5 in. And then I look at 5 times 12 to get 60. That's what I'm going to find my factors of. Sixty's got a lot of them. Because my signs are the same, I need to take the sum of my factors. And I need to find the combination that adds up to 19. And so that's going to be 4 and 15. Because my signs are the same, it doesn't matter where I put them. At this step, I have to look at both binomials and see, do I have a greatest common factor in either one of them? In the first one, 5n and 4, nothing common. But in the second one, I have a 5 in common, so I got to take that out of there. So I'm left with 5n plus 4, n plus 3. And I'm going to work it the other way over here. So I'm still doing this one over here. But I'm going to do it with the grouping way now. So I've got my 5n squared. That's not going to change. And then I've got my plus 12. That's not going to change. But I got to write that 19n a little more creatively to get 4 terms. I got to split it up. Now, because this sign right here is positive in my trinomial, that means I still got to use the same factors that add up to 19. So I'm going to write this as 4n plus 15n. And so I'm going to do this by grouping. I'm going to put my first 2 together and my second 2 together. Take out the greatest common factor between 5n squared and 4n, which is n. And I'm left with 5n plus 4. And then looking at my next 2 terms, my greatest common factor between these 2 is 3. So 15n divided by 3 is 5n. 12 divided by 3 is 4. And then I'm going to take that 5n plus 4 out. And then what's left is n plus 3. Let's go down here and do number 6. And again, I'm going to do them side by side. So the one on the right, I'm going to drop down with my 2 sets of parentheses. I know I've got a plus and a plus because this tells me the signs are the same. This tells me that they're both positive. And I'm going to come down with 2n, 2n. But I got to do 2 times 2 to get my factors. Because my signs are the same, I got to take the sum of my factors. And I got to use the sum that adds up to 5. And at this point, I need to find a greatest common factor if one exists and take it out of there. And that's factored. Going over here to doing the way of grouping is I'm still going to use the same factors that I used in this way. So it's not really that much different. So I've got 2n squared plus n plus 4n plus 2, and then grouping them. I factor out an n, I've got 2n plus 1. Here I factor out a 2, I've got 2n plus 1. Then I factor that 2n plus 1 out. And then I'm left with n plus 2. I am writing my n. And we're done. So I hope that helps you with factoring trinomials where a is not 1, where it's greater than 1. More importantly, it's not 1. Holler at me if you got questions. Y'all have a good one.